I still want to give you time for whatever closure you need for last Tuesday, or this 2 days ago lab. So I'm keeping an eye on the time. So there was a request about number 14 from the master set 03. So first, let's just talk about the slope. There's a couple ways of approaching it, but first we're going to deal with slope. Basically, they come in 4 varieties as far as what we care about right now: positive, negative, 0, and undefined. Which is sometimes why I quibble if someone says some object does not have a slope, or it has no slope. To me, that's different than it has a slope of 0. This tells me it doesn't have a slope. This is a slope of 0. They are two distinct things in my head. So first off, math definition, what is slope?
Rise or run.
Yep. So rise dealing with the change in the vertical, run dealing with the change in the horizontal. So if I have a straight line, I take 2 points on the line if it's straight. I look at how far did it rise, how far did it run, take the ratio. So if this is the point 1, 2, and this is the point 7, 6. When given a coordinate pair like this, the first number is the horizontal, the second one is the vertical. So this is, in math class, this would be the x and y. So my run, I'm going from 1 to 7. My rise, I'm going from 2 to 6. That's a 2 in there. So what's my rise?
6. Oh.
I heard a whole bunch of numbers being thrown out right there. If I'm going from 2 to 6, what is my rise? 4. I'm going from 1 to 7, what's my run?
6.
So my slope is 4 divided by 6, which is a legitimate answer, or 2/3 for those who like reduced fractions, or 0.666 who like the number of the beast. Now, in general, how can you tell if a slope is positive?
It's going up.
I want more specific than that. I suspect in your mind you have it perfect, but
Like if you're increasing,
is that increasing?
that's decreasing.
So going up and to the right.
Okay, up and to the right, or it rises as you go from left to right. Okay,
Wait, what do you mean? That would be decreasing, right? Because
if you go from left to right, it's
Yeah.
decreasing. If I go from right to left, it's increasing.
okay, all right.
That was the distinction I was making.
Okay, I was like confused for a second. Okay.
It might not have been a good time to nitpick, but
No, you're fine.
all right. So we know a slope is positive if it's like this. We know the slope is negative if it's like that. So this is a positive slope. All right. As you know, I don't like writing words if I don't have to. So in math class, what was the symbol they used for slope?
M.
Yeah. So unfortunately, we use M for meters, we use M for mass. I don't want to use M for one more thing. So for slope, what I usually use is a dollar sign. Got the S, except it doesn't look exactly like an S. So my slope is positive here. Positive slope, negative slope. What would a 0 slope be?
Oh, that's a straight line.
You said a straight line, did you?
Yeah.
More specifically,
Horizontal.
pardon?
Horizontal.
I'll buy that, or flat I would have gone for also. That's a straight line too, that's why,
Got you.
man, I'm just,
You're fine.
today's your day. Alright. No slope, and if you think about it, slope is a fraction here, it's a rise divided by a run. 0 slope means that rise is 0. In other words, it doesn't go up at all. So this is a slope is equal to 0 in whatever the appropriate units are. And then undefined,
Vertical lines.
because the math people still haven't figured out how to divide by 0, so that tells us that the run is 0 for undefined. So if I were doing a graph of velocity versus time, or actually any of the motion graphs versus time, and I had a vertical line there, that in essence would be an indication that something is now dead, or splatted, or whatever it happens to be. All right, so let's actually connect slope to this stuff over here. Velocity is the change in position over the change in time. Average velocity, more specifically. So this is a change in some vertical act. So if I have a plot of position and time, and I have 2 points on the line here, this is just my rise. That's how much my position changed from this point to that point. Delta t, that's my change in time. It's how much time passed from here to here. So my average velocity, or velocity, and I'll hopefully mention in a moment why I dropped the word average. My velocity is just the slope of my position versus time, or displacement versus time, either one. So velocity is slope of position versus time, or displacement versus time. And that's because if I have a position versus time graph, the only difference between that and displacement is what you consider to be your reference point. And so position versus time and displacement versus time is just potentially just a graph just shifted up and down. The slopes don't change at all.
Is that negative x?
Where are you looking?
What you just
Out
wrote?
at the top.
Oh, no, that's a straight mark from before.
Okay.
Okay, so if I have acceleration, that's the change in velocity over the change in time. And again, if I have a velocity time graph, if I have a straight line here, I got pick 2 spots on it. My rise is just the change in my velocity from here to here. My run is just a change in time from here to here. So my acceleration is just the slope. So how do you deal with a curve? A straight line, I think all of you have seen before in math class, if not other places. But if it's a curved line, how do you find the slope of, say, this point right here? Anyone know?
Can't you not actually find the slope? You have to find the slope of a trend line.
Wrong keyword. Not trend line.
Your resultant, don't you have to use your resultant?
No, not, I mean, ultimately you can connect it to that, but not what I'm looking for here.
Tangent?
That's the T word, tangent line. A tangent line is a line that basically skims off the curve. Officially, a tangent line is a line that's going to go through, it's going to stay on one side of the line or one side of the curve or the other in this area right here, but touch it only in one spot. So I'm not talking about a line that's going to cut through it like that. It's one that's going to go barely skim it. That's the tangent line. And so you're actually, when you're finding the velocity at this point, you're finding the slope of that tangent line. Now, if you're doing this by hand, if you've got a bunch of points here and you're trying to draw a tangent line, there's a certain amount of close enough that's allowed. As you get farther in math, you learn more sophisticated ways of finding it. For those who have calculus, a derivative. All right, so if I look at the slope at the beginning of this, and a slope here and a slope there. First off, the slopes, positive, negative, 0, undefined.
Positive. Positive.
All 3 of them. And what can you tell me about the slopes as we move in time?
They increase?
They indeed increase. That is a smaller slope than that is. That's an even bigger slope. Since velocity is the slope of this, that means my velocity is positive and my velocity is getting bigger. So if I plotted a velocity versus time graph, which is not exactly what the question asks there, my velocity starts out small and positive and gets bigger. Now, whether that's a straight line or curved line, it depends upon that. If this curve right here can be described by a parabola, if it's part of a parabola, that's a straight line. But, you know, there are other ways of drawing this. There's no real definition of this one. But the problem is asking, describe the motion necessary to create this graph. Well, you're traveling in the positive direction because the slope is all positive, therefore velocity is positive, and you're getting faster as you go.
What if we put one of those but not the other?
Then partial credit. Probably the important thing is going faster.
Well, okay, so that one is dealing with, output is dealing with displacement, it said displacement. So I figured if I put, you're moving in the positive direction, it makes more sense, cause you're talking about displacement.
All right, so here's why you need that little bit of extra. Let's take a look at this one then.
Okay.
Let's take the slope here, the slope here, and the slope here. What can you tell me about the slopes?
It goes from negative to positive.
Where do you see the negative slope?
Well, I considered I looked at the line, I didn't look at the slope on that one, so never mind.
Okay. So what else what can be said about the slopes?
The slopes remain positive, but they lessen in time.
Okay, now, the way I've drawn it here, you could make an argument that it's zero there, but the intent was that it was positive, just small. So here's an example. Also, my slope is positive the entire time, therefore my velocity is positive. So I'm traveling in the positive direction the whole time here and here. The difference is, here I'm speeding up, here I'm slowing down. And so that's why the distinction is necessary. Right. But recognizing it's traveling in the positive direction, and after I said that the other one was more important, I began to think, well, not necessarily, because I've seen enough misconceptions on the lab that you did on Tuesday and later today. And then the velocity one, a little bit trickier. And we can take a look at the slopes. Something like that. What can you tell me about these slopes?
Decrease.
Sorry?
The decrease.
Okay, so,
They become less.
and what else?
Negative.
Yeah, so just recognize that the slopes are getting smaller in the fact that if this is -1, that's -2, and that's -3, or something like that. It is getting smaller, but it's becoming steeper in a sense, so just be careful about the wording. So my velocity, all right, now let's take a look at the velocity graph. I think I established 0 was there.
Here's 1 there.
Say it again?
1.
Oh, I put 1 here?
Mm-hmm.
Okay. If that's 1, what can you tell me about the velocity? Is it positive or negative or 0? All right, velocity is positive, so I'm traveling in the positive direction the entire time. However, my acceleration, my slope is negative, therefore my acceleration is negative. So if my velocity is positive and my acceleration is negative, what am I doing? Exactly. And because it's getting steeper, what can you tell me about my slowing down?
It's happening quicker.
Yeah. So you lightly press on the brakes, then you press harder, and then suddenly you realize the car in front of you is actually stopped, so you slam on your brakes. So that's physically what these represent.
So what should we have put down for the middle one? Slowing down?
Traveling in the positive direction, slowing down at a quicker rate as you go, or an increase in the magnitude of acceleration. There are a couple ways of expressing it, but you're slowing down at a faster rate as you go. That would be ideal. Now, if you look at the master set 2 that's posted, and I do have one paper copy which I'll hand back. Please don't let me forget. I had stuff to hand back on Tuesday and I didn't do it, so please remind me if I forget. At the top of the page, you'll see the number of points, raw score points out of 220, and then you'll see a percentage, and then I don't have a letter grade on the paper that I'm handing back or on the electronic versions. You have to, if you want to see the grade, you go to, well, grade 1. But you'll notice that it's, I believe it to be a very fair and understanding grading system. So part of the, if you're thinking, oh no, I missed that one, I understand that you're in the learning process here, and so I'm not geeking you harshly. I'm not much of a believer in a set grading scale. You know, why is 10 points special? So getting below a 90 does not, or getting below a 60 does not mean you fail. To me, if you got 50, you got half of it. Not that you missed half, you got half. Any questions about this master set problem?
Overall, did we do good on the first master set?
There were moments, I thought, all right, people get it. And then there were moments I'm thinking, ooh, there are too many people. Like the force diagram problem. There were a lot of people who I wrote on the bottom of it, you need to watch the force diagram videos. Because what was presented in the master set looks nothing like any of the force diagram examples I've done. So, and there will be a force diagram problem on the test.
Yeah, I missed some points in my force diagram, but I still don't know like where they would go.
All right, so, as it, drop back, is the question of you're not quite sure what you missed, or you're not quite sure what?
I'm not quite sure what I missed, because I think you wrote what forces I missed, but I have no idea where they would go.
Okay, well, there were 34 forces total, 17 pairs. There was no other in it. Since your question is more specific to you, just at some point, I'll be glad to answer it directly. Speaking of the test, I said it originally was scheduled for a week from today, and let's just go ahead and make it the February 8th, the Tuesday after that. It just feels better, put it there instead of, someone just rush for next Thursday. Or this Thursday, what you people who use that language?
It's next Thursday.
It's still next Thursday, okay. And then master set 6-7 is now I pushed off to the 10th because I think that was originally scheduled for the 7th. I pushed that off to the 10th.
What master set? Sorry, I didn't.
All right, so the way I have it right now, master set 4 and 5 due on Tuesday. I think that was supposed to be due tomorrow.
Yeah.
So I pushed that off
So
to
that's
next Tuesday.
due Tuesday now.
Yes, master set 4 or 5 Tuesday. I've not updated Blackboard so that it'll still show up of, hey, you have this due, or it's late, or actually I'm not quite sure what message it sends you.
Will it close though? Will we still
Yeah.
be able to submit it?
You should still be able to
Okay.
submit. Officially, I don't think I have it closing until the last day of the semester.
Okay.
And then the master set 4 or 5, February 1st. The test, February 8th, and master set 6 and 7, February 10th. Now, if you can get 6, 7 done before the test, great, but if you need to concentrate on the test, at least it still gives you 2 days to work on 6 and 7.
if we miss the test on the 8th, I might be out of the country, can we take it in the testing center?
Yes.
Okay.
Let's make sure that, I'm gonna treat what you said as hypothetical for right now,
Yes.
and let's just talk individually if you need that. And the test is gonna be taken in here. If you have issues with taking tests in rooms with a lot of people, talk to me also. I have no problem if anyone can take it in the testing center. It's just some students have had issues with trying to schedule testing center time. And, oh, if you ever schedule something for the testing center and you go to pick up the test or quiz or whatever it happens to be, please make sure you're asking for the correct thing. For example, the 6 and 7 homework quiz is done together. It's a 2-chapter quiz. I had a student go down there and said that asked to take the chapter 6 quiz, and they handed her just this chapter 6. And then she had to reschedule for, I think, 2 weeks later to get the chapter 7 one done. So 6 and 7 go together. So please make sure you're asking for the correct thing. The person at the desk is not in the class and does not necessarily know the language. They just have, a document that says chapter 6 quiz, ignoring the fact that the page 2 is chapter 7 quiz.
So, for the due dates, Master Set 4 and 5 is due February 1st, the test is February 8th, and what's the other thing?
Master Set 6 and 7, February 10th.
Thank you.
Is that the only thing that you're gonna change right now, or?
Yeah, I need to look at the rest of it. This was sort of this feels right, and then I'll figure out what I'm doing about the rest of the dates.
Okay.
Would this also affect like when our textbook homework would be done as well? Like is that the same time as the master set in the next class?
Oh, when the textbook quizzes are,
Yeah.
it presumably will,
Okay.
but how it affects it, we'll figure out as we go. Again, I probably will, I suspect in late April, I'll figure out the timing I should have done for the semester. And probably in late April, you'll figure out how you should have done the course too, so. It'll work out well together as we come to our realizations at the same time. All right, so what I want to do before